My name is Sher and I'm a math and science tutor. Previously, you saw me do the entire math portion of the ACT. Today, I'll be attempting to do the science portion of the ACT. If you enjoy watching these sorts of videos, make sure to leave a like and subscribe so you get notified when future videos come out. Let's get on to it. Alright, here is the science portion of the ACT. And let's begin. According to Scientist 2, friction between the rocks and clay is reduced by which of the following? So, Scientist 2. Temperature when slick. When the surface gets wet, the top layer of clay transforms into a slick, muddy film. In addition, dormant algae grows rapidly. Presence of mud and algae. Reduced friction between the rocks and the clay. Alright. Suppose a researcher observed that wind speeds greater than 80 miles per hour are needed to move the rocks in the playa. This observation is consistent with which of the scientist's explanation? Okay. Large rocks have moved across the surface and then they are providing explanations. So scientist 1 thinks it's due to the combination of ice, mud and light winds, due to the combination of mud, algae and strong winds. And third scientist due to the strong winds. Alright, so it's going to be scientist 2 and 3 because scientist 1 thinks it's like winds, whereas 2 and 3 thinks it's strong winds. And 80 miles per hour is a strong wind. Alright, no seismic activity was recorded in the playa. This finding would weaken whose explanation? Alright. Ice, mud, light winds, combination of mud, algae, strong winds. Suppose that no seismic, so only scientist 3, because scientist 3's final explanation is tectonic plate movement. Particular rock formed a 200-meter long trail in 72 hours. Would this discovery support scientist 1's explanation? What is his explanation anyway? Okay, the rocks can move. So it's about rocks moving several hundred miles. Can move, yes. What is the few hours versus few days? Okay. So this says a few days, so we're going to strike out anything that says a few hours. Particular rock formed in 72 hours. And 72 hours would be about days. So yes, it's going to be true. Suppose that during 1 year there is no measurable movement of any rocks in the playa during spring. Scientists 1 and 2 would most likely both agree that this was due to the absence of which of the following factors. We just have to see what do they agree with. Ice, I don't see ice. Mud, algae. Is there algae? Mud then. It's just going to be mud. Is there one about mud? Nope. Due to the combination of ice, mud, light winds, mud, algae, and strong winds. So we're just going to have to strike out a few then. It's not going to be algae because scientist 1 doesn't think it's algae, nor strong winds. We're going to see snow melt and sub-zero temperatures. Ice melts, buoyancy, ice, blah. Shallow and only about snow melt. Okay, it's going to be about snow melt because both of them, their explanations start with snow melt. Suppose that air temperature in the playa varies between 4 and 47, which this information supports the explanation of scientist 2. Just correct. However, the temperature in the playa does not get cold enough for ice to form. Does not get cold enough for... Yep, it would support him because ice cannot form in that temperature range. So yes, F. Based on scientist 1 explanation, a rock trail that is 33 meters wide was most likely made by a rock with approximately what width? Well, what did he say? Evidence of this lifting is seen in the trails left by rocks that are both shallow and only about 2/3 as wide as the rock itself. So the trail is 2/3 as wide. Okay, so 2/3 is equivalent to 33. So 1/3 is, so if you want 1/3 is basically 33 divided by 2. And we would get 16.5, and if we want 3 out of 3, we have to multiply that by 3 to get what, 49.5? C. Ooh, that was what? Okay, that's question 7, so we're looking for question 8. If another trial had been performed in experiment 2 and this much of liquid was measured in the cylinder, the temperature of the Diet Cola in this would have been likely been where is experiment 2? Okay, what are they doing here? A bottle, a jar, a granulated cylinder. When certain substances are added to Diet Cola, carbon dioxide is produced, generating a foam. 2 experiments were done. Okay, so we are talking about mass of, okay, at higher temperature, basically I talk about different temperatures, the volume of the liquid in the cylinder will decrease. Which one? This one? And the amount of carbon dioxide decreases. Okay. So another trial and 450, so it's going to be lower than that. So we can tell if the trend goes down, the temperature will go up, something higher than 60. There we go, J. Suppose trial 6 had been repeated, but the bottle of Diet Cola had been opened and then left undisturbed at 25 degrees Celsius for 12 hours before it was added. It would be less because more of the carbon dioxide would have fizzled away. There we go, C. 1 millimole of carbon dioxide has a mass of that. How many trials resulted in the production of at least 1 millimoles of carbon dioxide? Okay. Let's try to look at this one. Oh, okay. These are all in grams. Has a mass of this. At least we're looking for 0.044. Well, all of these have at least 0.044 grams. And so do all of these too. So all of the experiments basically, J. According to figure 1, which of tube A and B, if either, had at least one end submerged in liquid before the clamp was removed? Which of tube A, according to figure 1, this one. Which of tube A and B, if either, had at least one end submerged in liquid before the clamp was removed? Submerged in the liquid before the clamp. Well, just one. I mean, I'm looking at the diagram. It looks like only tube B. Only tube B. Is the relationship between the volume of the liquid in the cylinder and the mass direct or inverse? So when we less liquid, less gas. So there it's a direct. It's because as the liquid increases, the mass also increases. So direct would mean if one increases, the other increases as well. Consider these steps that are performed in each trial. Removing clamp, measuring liquid in cylinder, inserting a solid substance into tube A, attaching tube A to a bottle of diet soda. According to the procedure, these steps were performed in what sequence? Well, obviously 2 is the last, you have to measure that the last, and then you remove the clamp that's before that, so it's obviously going to be B or D. Now, do we do 3 or 4 first? 3 first, you've got to insert it in before you can stick the tube inside. So it's going to be B. Assuming that room temperature is 25, how many trials were tested at a temperature lower? Okay. So all of this, table 1, everything was done at 3 degrees Celsius. So it's going to be 1, 2, 3, 4, 5. And do we count lower? So 1, 2, 3, 4, 5 of them, H. Alright. I call it question 15. According to figure 1, as the nickel concentration increased, the average iron content of species M is the square, or decrease. It just decreased, right? It just decreased only. Alright. According to Table 1, the species U plants that were fed the solution had a pH of 6 and nickel concentration of 10, had an average dry mass of Table 1, species U. Table 1, species U that were fed the solution that had pH of 6. Where is this? 9.2, had an average dry mass. Oh, we just have to read this table. And a nickel concentration of 10. 6. pH 6, 10, it's going to be 8.1 if I'm reading this correctly. pH 6, nickel concentration of species U, pH 6, nickel concentration of 10. It's 8.1. Alright, according to Table 1, species M were fed a nutrient solution with which of the following combinations of pH and nickel concentration had the greatest average dry mass? Alright, species M. We want the greatest, so it is it one of these two? I'm just trying to look at the numbers and see. Alright, it's going to be one of these two. It's 33 the one that gives us 33.96655. It's definitely not 5. 5 gives you a smaller dry mass. It's either 6 or 5. It's going to be 6, 0 right here. It's going to be A. According to Table 1 in Figure 1, species M that was fed, plants that were fed solution 3 had an average zinc content of M solution 3, nickel concentration of 10, and they want zinc M3, which is 10. Which one's M? The square 100, just from the graph. Alright. According to Table 1 and Figure 1, for the species M plants that were fed solutions 1 to 4, what was the order of the nutrient solutions from the concentration that result lowest average iron content to the solution that resulted in the highest average iron content? Alright, wait 1 second. Species M, this was... Did I not read this right? Oh, we're talking about zinc then. So back to 18. Alright, I did not read it properly. They wanted zinc, not iron. And zinc is this one. Squares should have been 200. Right? What about this one? Lowest average iron content to the solution that resulted in the highest average iron content. And solutions 1 to 4. So 1 to 4, 0 to 4. And are we talking about which species? Species M and also iron. That's this one. So we're talking, it's probably 4, 3, 2, 1 then. Alright, Table 1, compared to the average dry mass of species U plants that were fed solution 3, the dry mass of species M that were fed solution 6, U that was fed solution 3, M that was fed solution 6, M that was fed solution 6 was approximately 3 times more. 3 times, that's great. Alright. And that was the first half of the science portion of the ACT. Now I'll be honest, I have never seen the science portion of any ACT test before, so this was a little new to me. This honestly feels more like logical reasoning than science. It didn't really test you anything about biology, chemistry, or physics, which is what I was expecting. And instead, it tests your ability to read data and come to your own conclusions and apply the knowledge from one table to another table, something I was not used to. Now, the SAT has data reading questions, but it doesn't expect you to extrapolate results from one table to another, whereas the ACT does. It took a bit of getting used to, but in the end, I think if you are able to think logically and read each question properly, you should have no problems with the science section. Anyway, if you enjoyed watching the video, make sure to leave a like and subscribe so you get notified when part 2 of the science section comes out. Thanks for watching and happy holidays!